Hello everyone, welcome to our channel Mathematics Parshala. This is a CSIR NET December 2023 problem, Mathematical Sciences. This is a problem of Abstract Algebra, Part C. The question ID 704086, and this is a problem from ring theory related to prime ideal and some related to ideal actually, and especially prime ideal. So first we read the question. Let R equal to Zx by this ideal generated by this x square plus 1 and psi such that Zx to R be the natural quotient map. Which of the following statements are true? Option 1 says that R is isomorphic to a subring of C. Option 2 says that for any prime number p belongs to Z, the ideal generated by psi p is a proper ideal of R. Option 3 says that R has infinitely many prime ideals. Option 4 says that the ideal generated by psi x is a prime ideal in R. So the question is about the ring R, that is the quotient ring Zx by this ideal generated by x square plus 1. So we have to study about this ring R here, and we are given that psi is the natural quotient map. So it is defined by very usual way. Psi from Zx to R is defined by, if we take any polynomial fx belongs to Zx, then psi fx will be fx plus this ideal generated by x square plus 1, because R is the ring Zx quotient this ideal x square plus 1 generated ideal generated by this, and so any element of R is of the form some polynomial say phi x plus this ideal generated by this. So for simplicity, let us suppose this ideal generated by x square plus 1 is, we denote this by I. So we write it Zx by I, and any element of R is of the form phi x plus I, and psi is a map defined by this, so we write this map as fx plus I. Now look at option one by one. So look at first the option to the option 1 first. R is isomorphic to a subring C. So very clear that the characteristic of this ring R is 0. So as the characteristic of R is 0, so if we consider the quotient field of R, so it must be either Q or R or C, whatever, or some field may be between R and C, that is actually a subfield of C. So this quotient field is a subfield of C. So we must have this ring R is isomorphic to a subring of C. As this quotient field is a subfield of C, so R must be isomorphic to a subring of C. So option 1 is true here. Actually, we know that there are two types of fields. One is infinite field, and that is Q and some extension of Q up to C. And for finite field, the characteristic is must be a prime number like ZP. That is ZP actually. So in this way, we can find that as the characteristic of R is 0, so ring, this ring is a subring of C, as the quotient field of this ring is a subfield of C, like that. Okay, so option 1 is done. Now look at option 2. For any prime Pz, the ideal generated by psi p is a proper ideal of R. So what is psi p here? So for option 2, what is psi p here? Psi p is defined by simply p as a polynomial, that is constant polynomial in Zx plus this ideal I. So this is psi p here, and it says that the ideal generated by psi p. So this ideal, actually this p plus I is only an element of this R, and the ideal generated by this element, that is generated by this element p plus I in R, we have to examine that if this is a proper ideal or not. So to do this, let us first study about this type of ideals. That is, if we take any element, say phi x belongs to Zx, then what is this type of ideal generated by this phi x plus I? Okay, for in particular, we only study about this type of ideal that is generated by psi p. So no need to for general any consider the ideal generated by this psi of phi x. Just we consider and study this type of ideals that is generated by psi p. So we will study about this ideal that is generated by this element p plus I. So we now study about this ideal. So first, take one element, let one element from this ideal, suppose phi x plus I belongs to this ideal. This ideal generated by p plus I. Then what happened? Then this phi x plus I is equal to this p plus I into some element, say fx plus I. We know that any element of this ideal is of the form this. So then this is actually pfx plus I in the definition of quotient ring. So now this is actually phi x minus pfx belongs to I. A plus I equal to b plus I if and only if a minus b belongs to I. So using this we get this. Now as this I is the ideal generated by this x square plus 1, we have supposed first. So this element belongs to I. So this is of the form x square plus 1 into some polynomial in Zx, that is we suppose it as gx. So what we get ultimately, that phi x equal to pfx plus x square plus 1 gx, that is actually phi x belongs to the ideal generated by p comma x square plus 1. So now this result is all about the form of an ideal in a polynomial ring with connection the form of an ideal in one quotient ring. So all these implications are both sided, so we can write this. So now what we get ultimately, that one element belongs to P plus I, this ideal, that is if and only if, we get, we get this thing, that phi x should be in this ideal. So now it will help us to examine, to check all the options. So now look at option 2 again, that for any prime number p, the ideal generated by psi p is a proper ideal of R. So we take one prime number, arbitrary prime number, and consider that we consider that uh, now this ideal psi p generated by this psi p is proper or not. So that is ideal generated by this p plus I. So now, if possible, let it is not a proper ideal. So the unity in this ideal R, that is 1 plus I. So 1 plus I will belong to this ideal P plus I, and we just studied that 1 plus I belongs to this is if and only if 1 belongs to this ideal generated by p comma x square plus 1. Just we studied from, we can write it 1. So from option, from 1 we get this. So now 1 belongs to this. So we have 1 equal to p into some polynomial, say phi 1x, and x square plus 1 into polynomial, say g1x. So clearly, as it is, we are in integral domain, so integral domain is zx, not, we are saying R is an integral domain, we are saying that zx is an integral domain, and we are in zx now because this 1 belongs to zx and this ideal is an ideal of zx. So we are now in zx, so it is an integral domain, so this must be 0. So we have 1 equal to p into some phi 1x must be a constant polynomial, say some a. So this implies that p is a unit, which is a contradiction as it is prime. So if we suppose that 1 plus I belongs to this, so it is a contradiction. So we have 1 does not belong to this ideal generated by p comma x square plus 1, that is actually this 1 plus I does not belong to this ideal generated by p plus I, that is psi p. So we have this ideal generated by this psi p is a proper ideal. So option 2 is the correct option. Now look at option 3. R has infinitely many prime ideals. So for this, option 3, for option 3, R has infinitely many prime ideals. So first see that we have a standard result. In one of our video we have proved this result, and using this we have solved some problems. So the result I am just writing here, that is zx by the ideal generated by p comma some fx is isomorphic to zpx by the ideal generated by this fx bar, that is fx modulo p. So here in particular we are writing this zx by this p comma x square plus 1, that is isomorphic to zpx by this x square plus 1. When we take it using modulo p, then we also get this. So using this result we can easily see that there are so many prime ideals. Like if we take simply p equal to 3, then see here we have this zx 3 comma x square plus 1 is isomorphic to z3x. By this actually we are calling this as I. Okay, so now clearly this polynomial x square plus 1 has no root in z3, and as z3 is a field and this is a polynomial of degree 2, so we can say that it is irreducible in z3x or over z3, same thing. So this is irreducible in z3x. Irreducible in z3x. So this polynomial generated, the ideal generated by this polynomial is maximal ideal as it is a PID. So as z3x is a PID, so it is maximal ideal in z3x. So this quotient ring, that is z3x by this ideal generated by this, will be a field. So as this is a field and this is isomorphic to this, so we have this ideal is also a field. This ring is also a field. That is, which is zx by the ideal generated by 3 comma x square plus 1. So this is a field. So this is a field implies that this ideal which quotient zx, that is 3 comma x square plus 1, is a maximal ideal. Just we are using the standard result, very useful and standard results. So as this is a maximal ideal, so we must have this ideal must be a proper ideal. So this is a proper ideal, and as this is a proper ideal, we must have very sorry, we don't need to use this proper ideal. This is maximal ideal, so it is prime ideal. So it is prime ideal. Know that every maximal ideal is prime ideal. So it is prime ideal. So as this is prime ideal, so we have uh okay. So this is prime ideal means this is the integral domain. So we have this this is integral domain. Actually what we need, we are showing that the ideal generated by psi 3 is a prime ideal, and similarly we get all many other prime ideals. So we have to show that psi 3 is a prime ideal. Sorry, ideal generated by psi 3. So we are trying to show here that the ideal generated by psi 3, that is 3 plus I, this ideal, we are trying to show that this is a prime ideal. So for this, so to show this, so now what we get? We get that this ideal, this 3 comma ideal generated by 3 comma x squared plus 1 is a maximal as well as prime ideal. So we have to show that this ideal generated by psi 3 is a prime ideal. So if possible, suppose it is not a prime ideal, so we must have two elements, say phi x and psi x, such that uh, sorry, we have to okay, in just we have show that any element from this result 1, that any element phi x plus I belongs to this ideal generated by p plus I is same as well as phi x belongs to the ideal generated by p comma x squared plus 1. Okay, so we have to use this result also here. So let me write this result again. So we are writing this result here again, that some phi x plus I belongs to this 3 plus I, writing here p equal to 3 for simplicity. This if and only if phi x belongs to this 3 comma the ideal generated by x squared plus 1. So now, and we get here that this ideal is a maximal ideal, so it is a prime ideal. So if we suppose that this is uh, uh, not a prime ideal, then we must have some phi x plus I and psi x plus I belongs to R, such that this phi x plus I and psi x plus I both does not belong to this ideal generated by this 3 plus I psi 3, but their product, that is phi x plus I into psi x plus I will belong to this ideal generated by 3 plus I. So if possible, suppose this holds, that is there exists two elements such that they are not in this ideal but their product in this ideal. If we try to counter that it is a prime ideal, so then we have that phi x psi x plus I belongs to this ideal generated by 3 plus I, and by our this result 1 we have then this phi x psi x belongs to this ideal generated by 3 comma x square plus 1, and we just using again this sorry, this is from result 1. So now we just proved that this is a prime ideal. So as this is a prime ideal, so we must have either phi x belongs to this here, as this product belongs to here, or this psi x belongs to here. So when this phi x belongs to here, then we have again by this result 1 that phi x plus I belong to this ideal generated by 3 plus I, that is psi 3, and when psi x belongs to this, then we have this ideal psi x plus I, this element belongs to this ideal generated by 3 plus I psi 3. So which is a contradiction, as we have supposed that these both are not in this ideal generated by 3 plus I. So what we get, so if this shows that this phi x plus I into psi x plus I belongs to this ideal, then one of these must belong to this ideal. So we must have this ideal generated by this psi 3, that is 3 plus I, is a prime ideal. So now in this way we can prove that similarly that the ideal generated by psi 3 is a prime is sorry psi 7 is a prime ideal. We can similarly prove that the ideal generated by psi 11 is a prime ideal. In same way, all such psi p, all such psi p will be all such ideal generated by psi p will be a prime ideal when this fx, that is x square plus 1, does not have a root in zp. So for all such p such that f x square plus 1 does not have a root in zp, for those p exactly in similar manner we can show that all such ideal generated by those psi p is a prime ideal. So what we get, R has infinitely many prime ideals. So we have R has infinitely many prime ideals. Now look at option 4, the ideal generated by psi x. So it is not a prime number p psi x, it is a the element that is a polynomial of degree 1 x generated by this element is a prime ideal or not. So we now show that this actually is not a prime ideal, because just take x plus 1, this is for option 4. If we take x plus 1, so clearly x plus 1 is not in this ideal, x comma x square plus 1. But this x plus 1 into x plus 1, that is x plus 1 square, and which is actually x square plus 2x plus 1, that is x square plus 1 into 2x. We can write this 1 into this plus 2 into x. So it belongs to this ideal generated by x comma x square plus 1. So what we get here? So this x plus 1 does not belong to this, but x plus 1 into x plus 1 belongs to this. So this implies that this ideal generated by this x and x square plus 1 is not a prime ideal. It is not a prime ideal. So by our result just proved here that it will imply that the ideal generated by x plus I, that is ideal generated by psi x, will not be a prime ideal, because the proof is very easy. Because if we suppose that sorry as this x plus 1 does not belong to this, then here we have this x plus 1 plus I. This actually does not belong to this ideal generated by x plus I. But if we take the square of this ideal, that is x plus I into x plus I, then it gives that x plus 1 square plus I and this will belong to this ideal, that is this ideal generated by x plus I. Because we can write this element, that is x plus 1 square plus I, this is actually x square plus 1 plus 2x plus I. So we can write this as x square plus 1 plus I plus 2x plus I, and as this x square plus 1 belongs to I, because I is the ideal generated by this element, so it is simply I plus this 2x plus I. So it is 1 plus 0 plus I plus 2x plus I, so this is 2x plus I, so it is actually 2x plus I. So it is 2x plus I. So now what we get, that this element x plus 1I into this x plus 1I, that is, we are writing again what we ultimately get here. We get here this x plus 1 plus I into this x plus 1 plus I belongs to, this is actually 2x plus I, that is, this belongs to the ideal generated by x plus I. But this x plus 1 plus I does not belong to this ideal generated by x plus I. So this thing implies that the ideal generated by this x plus I, that is the ideal generated by this psi x, is not a prime ideal. So now look at option 4. So now the ideal generated by this ideal is prime ideal in R. It is not the correct option. So here option 1, 2, 3 are the correct options and option 4 is not the correct option. So the solution is very lengthy, not very complicated, but lengthy, because we have to study all such options one by one. So this is the solution.